rises. Now mind you, this air is laden with moisture, right, because it is rising from the oceans, that too in the tropical areas, right. So this air, as it rises, the temperature, due to adiabatic compression, the temperature of this column of air will fall such that there will come a point when the temperature is so low that the air tends to lose its moisture, right, and undergoes condensation, and results in the formation of clouds. Okay, so what has happened is, the warm air is rising. This is, say, a weak low pressure area, say a thunderstorm. This is also a weak low pressure area, say a thunderstorm, right. So air has risen, right, warm air rises, so air has risen. As it rises, the temperature of the column of air forms, its capacity to retain moisture also falls. Eventually it reaches a point where the column of air undergoes condensation, right, and loses its moisture. So this process of condensation or formation of clouds results in what we call as the latent heat of condensation, results in the release of latent heat of condensation, right. So this heat that is released in the process of condensation will causes the air in this region to rise even further, right. So presence of latent heat of condensation is a major factor why tropical cyclones, they are present only over the oceans, they dissipate on land, right, and they are so intense, right, because when latent heat of condensation in itself causes the column of air to rise even higher, right, so tends to strengthen the low pressure system, right. So this is about the early stage of formation of tropical cyclone. What has happened is, multiple low pressure areas, that is thunderstorms, they have combined together. The air has risen to a level that it undergoes condensation due to adiabatic compression, right. So in the process of condensation, latent heat is released and the system goes on sustaining itself. Now also what happens is, see, this is the low pressure area. Now as the air is rising above, it tends to form a spiral, okay. Now why it tends to form a spiral? Due to the presence of the Coriolis force, right. So that is why this leads to the formation of the cyclone vortex. That is why the presence of Coriolis force is one of the pre-existing important conditions that is required for the formation of a tropical cyclones. Right. So this is a basic depiction of the process. We have warm air rising, ultimately reaching a height where the temperatures have fallen so much that the air column undergoes condensation. It loses its moisture to form clouds, okay. The air eventually that has cooled down, it starts moving downwards, Okay, so I is the region where the column of air is descending. Supply of moisture from the sea is one of the reasons why this system is sustaining itself, right? So if this supply of moisture is cut off, the system will eventually dissipate. That is one of the reasons, that is the tropical cyclones, they are formed or present only over the oceans, and they dissipate while they reach the coastal areas. Okay, so next we come to the structure of a tropical cyclone, right? So a tropical cyclone basically consists of three parts. We have the eye wall, eye in the center, the eye wall surrounding the eye, and the rain bands, the spiral rain bands that radiate from the eye wall, right? So what is the eye, right? As you can see on your screens, the eye is the center of the tropical cyclone. Its diameter varies from 80 to 200 kilometers, right? The eye or the center of the tropical cyclone is a region of calm, right? A region of calm means very light winds and clear skies. Okay, very light winds and clear skies means there is an absence of rainfall, absence or very light rainfall, right? It is a region of subsidence of air. We know that eye wall is a region of upward movement of air. So eye is a region of subsidence of air or air moving downwards. Hence the reason why clouds are not formed and there is less rainfall. Okay. So main characteristics of eye, it is a region of calm, subsidence of air, light winds, clear skies and absence of rainfall, right? So there is scientists, they have different opinions about how this eye comes into existence, but there is a general theory that is stated is that eye is a result of a combination of centrifugal force plus conservation of angular momentum. Okay. Conservation of angular momentum. Right. So it is a combination of the action of centrifugal force and the conservation of angular momentum. Momentum of bodies that rotate is, in layman's term, this is what defines the angular momentum, right? Next we come to the eye wall. Now eye wall is a region of, surrounds the eye is a region of deep convection. Convection, that is warm rising air, right? So it is a region of deep convection, it is a region of heaviest, strongest winds, it is a region of strong clouds, right? It is a region of heavy rainfall, right? Region of cumulus or cumulonimbus clouds, and a region of upward or upliftment of air, upward movement of air. Okay, so these are the basic features of the eye wall, right? Next is the rain bands. Rain bands are nothing but the clouds, as you can see on your screens, the clouds or bands of clouds that radiate away from the eye wall. Okay. So this is about the structure of a tropical cyclone. What is important in this tropical cyclone is, firstly you need to know what are the conditions for the formation of tropical cyclone, right? Then you need to know the structure of the tropical cyclone, also the diagram in certain cases. Then you need to know the association of tropical cyclones with the prevailing wind systems, right? Then a little bit in brief about the formation of the tropical cyclones. Okay. Okay, so in the last lecture we had discussed about what are cyclones and what are tropical cyclones. Now in this lecture we will be discussing about air masses and extratropical cyclones, right? So before we begin with extratropical cyclones, which will be a main topic, we have to understand what are air masses, right? Now, consider in a packet of air, like a column of air, right, which is extensively large in dimensions, right. All across this packet of air has uniform temperature and humidity or moisture, right. So this is a very large column of air, right, very extensive, which has a uniform temperature and moisture conditions all across with very little horizontal distinction, right. So this column of air is something that we call as an air mass, right. So how does this air mass come into existence? So now we know what is an air mass. Air mass is a column of air that has a distinct temperature and moisture conditions with little horizontal variation in these conditions. Okay. So what are the key words? It is extensive, right. It has its own distinct temperature and moisture conditions, right, and little horizontal variation in these two. Which temperature and moisture? Little horizontal variation in temperature and moisture. Okay. So how does this air mass come into existence? Consider a very large area on the surface of the earth, right. Say the subtropical hot deserts, okay. So thousands of kilometers, a very large area, and that too a homogeneous area, right. So the column of air that is existing around this extensive land region, that is your subtropical hot desert, tends to develop its own distinct temperature and pressure, right. So this subtropical hot desert region has a temperature and moisture condition of its own. The air column above this extensive region tends to develop its own distinct temperature and moisture conditions, right, with very little horizontal variation. What does this mean? That if you move from say point here to point here, there will be very little horizontal variation, or in other words uniformity or homogeneity, right, such that this column of air in together can be called either a cold air mass or a hot air mass, right, because the temperature will not tend to differ much, right. So this subtropical hot desert, which over which this column of air is existing is a hot source region. Okay, so the region in which these air columns are in contact with, they are known as the source region or the source of these air columns or air masses, right. So these tend to be both land areas as well as your ocean areas, right. So source regions can be both land as well as your oceans, right. So both land and ocean can act as source region for the development of air mass. The characteristic of the resulting air mass will depend on the source region that it is in contact with, right. So a hot source region will result in the development of a hot air mass, a cold source region will result in the development of a cold air mass, right. So what we have done up till now is, what is an air mass? Air mass is an extensive column of air with its own distinct temperature and moisture conditions in contact with the source region with little horizontal variation, right. So this is the definition of an air mass that sums up its characteristics, right. Another thing, okay, so I forgot this, another thing is the air mass and the source region eventually, so there is an exchange of heat and moisture between the two such that eventually they reach an equilibrium within themselves, right. So after that equilibrium is reached, it has a consistent temperature and pressure. Now how extensive are, what is the height of these air masses? They extend right from the surface up till the lower, they can be as extensive as the lower stratosphere, right. So next we come to the types of source region. Now it has been observed that a source region is usually a region of gentle divergent airflow. Okay, now what do we mean by this? Gentle means very little pressure gradient or very little pressure variation, right. Divergent airflow means a high pressure area, right. So usually it has been observed that the source regions are regions that have little pressure gradient and are high pressure areas with divergent airflow, right. So there are 5 main types of source regions. Firstly, we have the warm tropical and subtropical oceans, right. Then we have the subtropical hot deserts, okay. So hot regions, both oceans and land have been covered. Then we have the relatively cold high latitude oceans, okay. So oceans in the temperate and middle latitudes. Then we have very cold continental regions in high latitude such as the Siberian region. And then we have the permanently